Hey everyone, welcome back to the channel. Right now, amateur astronomers around the world are capturing images of something in our night sky that's completely baffling scientists. Loeb just dropped new information about Comet 3I Atlas, and what we're seeing in these latest photographs is raising serious questions about everything we thought we knew about how comets behave. The observations from November 16th and 17th are so unusual that physicists are genuinely stumped trying to explain what's going on up there. This isn't just another space rock passing by. Something is happening with 3I Atlas that defies the normal rules of comet physics, and the more we look at it, the weirder it gets. For nearly 2 weeks back in late October, 3I Atlas completely vanished from our view. It disappeared behind the sun, and ground-based telescopes couldn't track it at all. We were flying blind, waiting for it to emerge on the other side. Then, on November 6th, the Virtual Telescope project managed to capture the first decent images of the comet as it came back into view. The challenge was massive because 3I Atlas was sitting only 12 degrees above the horizon, which is incredibly low for any kind of quality observation. Despite that brutal viewing angle, astronomers could already make out the ion tail starting to form. Just 3 days later, on November 9th, everything changed. The images got dramatically better, and suddenly, that tail became much more prominent and visible. As the viewing geometry improved over the following days, we started seeing details that nobody expected. By November 11th, the images were showing an ion tail stretching across an absolutely mind-blowing distance of about 1 million miles through space. The tail was pointing northeast, which makes perfect sense because that's directly away from the sun. This is exactly what you'd expect from a normal comet. But then astronomers noticed something else in that November 11th image, something that shouldn't be there. There was a faint structure pointing in the opposite direction, back toward the sun. Then on November 15th, an astronomer in Thailand captured an even more detailed image that changed everything. Both tails were now clearly visible at the same time. The anti-tail wasn't just a faint anomaly anymore. It was super bright and sharply defined. And then came November 16th. That's when we got what might be the most spectacular image yet. The detail is absolutely stunning. You can see the bright central coma glowing intensely. The main tail is sweeping away from the sun just like it should. But those jets pointing sunward are right there, clear as day, and they're not supposed to exist. Tell me what you think is really going on with 3I Atlas. Is this natural physics we don't understand yet, or are we looking at something else entirely? Let me know your theory. Understanding what's happening with 3I Atlas requires understanding how comets normally work, and that's where this whole situation gets absolutely bizarre. When a comet moves through space, the sun is constantly blasting out charged particles in every direction at speeds exceeding 800,000 miles per hour. This is called solar wind, and it acts like a massive cosmic leaf blower pushing all the gas and dust from a comet backward, away from the sun. That's why comet tails always point away from the sun, no matter which direction the comet itself is traveling. It's basic physics that we've observed thousands of times. But 3I Atlas is doing something completely different. Starting on November 11th, images clearly showed material pointing toward the sun instead of away from it. These are called anti-tails, and they're extremely rare. We've seen them a few times before in comet history, but those cases were always optical illusions. When particles fall behind a comet as it moves, certain viewing angles can make it look like there's a tail pointing sunward, when really it's just a perspective trick. But what we're seeing with 3I Atlas is not an illusion. Multiple telescopes from completely different locations around the world are all capturing this same structure. It's real. There's actual material streaming toward the sun, and that creates a massive problem. The solar wind should be pushing everything away. So what kind of material could possibly resist that force? Why isn't it being blown backward like it's supposed to be? The brightness and sharpness of this anti-tail is shocking. It's not some faint, wispy structure that could be explained away. It's prominent, well-defined, and getting clearer in every new image. Something is fundamentally wrong with our understanding here, and scientists are scrambling to figure out what's actually happening up there in space. So, how do we explain this anti-tail? Scientists have come up with 3 different theories, and honestly, every single one of them has serious problems that don't quite add up. The first explanation suggests that 3I Atlas is ejecting absolutely massive dust particles. Let's talk about the math here because it gets wild. Normal comet dust is about 1 micrometer in size. That's 1/1,000,000th of a meter. Incredibly tiny. For dust particles to punch through the solar wind without getting pushed away, they would need to be about 100 micrometers in radius. Now here's where it gets crazy. A dust particle with a 100 micrometer radius is actually 1,000,000 times more massive than a typical 1 micrometer particle, assuming they're made of the same material. Because these hypothetical particles would be so incredibly heavy, the solar wind couldn't deflect them. They'd launch out behind the comet and create this anti-tail pointing toward the sun. But there's a massive problem with this theory. To produce the brightness we're actually seeing in these photographs, 3I Atlas would need to be ejecting 100 times more mass than it would with normal-sized dust particles. That's an absolutely enormous amount of material being thrown off. But we already observed that the comet didn't change its size after passing closest to the sun during perihelion. The math just doesn't work. The second explanation involves chunks of ice instead of dust. When ice gets ejected from the comet, it immediately starts sublimating because it's exposed to direct sunlight. These ice fragments would scatter sunlight just like dust does, making them visible. But they typically evaporate before they have a chance to turn around and form a traditional tail pointing away from the sun. From our viewing angle, we'd see this bright structure pointing toward the sun that's actually just evaporating ice. The problem with this theory is that for ice fragments to create the brightness we're observing, they'd need to be pretty large. And if they're big enough to scatter that much light, they probably wouldn't evaporate fast enough. They'd stick around long enough for solar wind and radiation pressure to eventually push them away. This explanation kind of works, but only if the ice fragments are exactly the right size to scatter enough light while also evaporating quickly enough. That's an incredibly narrow window of conditions. The third explanation is the one that about 80% of people seem to believe without question, though it's the one I personally find least likely. We've seen objects in our solar system before that looked like comets but turned out to be technological. NASA rocket boosters, SpaceX debris, things like that can look like dark comets from a distance. If these jets are coming from thrusters instead of natural outgassing, they'd be moving so fast that solar wind couldn't deflect them at all. They'd punch straight through and create these tightly collimated beams pointing in whatever direction the thruster happens to be aimed. This would completely explain why the jets point toward the sun. They wouldn't be pushed by solar heating, but rather aimed by some kind of propulsion system. Each theory has appeal, but each one also requires us to accept something extraordinary. Here's what makes 3I Atlas even more remarkable. This object survived its closest approach to the sun without breaking apart, which is actually pretty unusual. A lot of comets fragment when they get that close because the thermal stress is absolutely intense, but 3I Atlas made it through intact. Images from November 11th clearly show one solid object, not fragments or pieces spreading out. Just one nucleus with jets and tails emanating from it. Right now, you can get a telescope for around $500. That's powerful enough to see objects this far away. The Virtual Telescope project is hosting live streams where you can watch this comet in real time. The ion tail keeps growing. The antitail remains prominently visible. The coma is bright and sharply defined. This thing is putting on an absolute show in our night sky. But here's the key thing to watch moving forward. Natural comets always get less active as they move farther from the sun because they're receiving less solar heating. That's just how it works. If 3I Atlas stays active and those jets continue even as it gets farther away, that would be genuinely weird. That would suggest the energy source isn't coming from the sun at all. And if that's the case, we're looking at something that challenges everything we understand about these objects. Technology has given amateur astronomers the ability to capture incredibly detailed images that rival professional observatories from just a few decades ago. We're living in an era where regular people can contribute to solving mysteries like this. The data keeps coming in, and every new image adds another piece to this puzzle. Let me know down in the comments which explanation you find most believable. Is it giant dust particles, evaporating ice chunks, or something else entirely? Drop your thoughts below, and don't forget to smash that like button if you want more content like this.